right, it's 8 o'clock and it's still bright out. This is the part of spring, summer that I like the most. You have beautiful, beautiful long days. Well, we'll get a nicer weather soon, right, Matthew? Adam Smith, I wish you were here to read this lesson for everyone because there's going to be a lot of word problems. Anyway, I'll try to do my best. So we are going to continue our lesson. I have not checked your homework assignments from yesterday, but if you anyhow struggled, make sure you reach out for help because that is an important part. And for this that we are going to be doing today, we are going to use what we did yesterday. I had more friends today during my office hours and we did those questions together, and it's like with everything, when we do it together, then it's much easier than when you are to do it by yourself. So today we will talk about the velocity and a couple definitions before. So first of all, if we think of a speed is a distance traveled divided by the time it took to cover the distance. Okay, let's keep this in mind. Velocity is the speed with the added dimension of direction. You can calculate it using the same approach as finding the average speed. So, well, in other words, we are going to kind of find a slope, and we will be able to find the average velocity. So we will have some point. The point is going to have a y value. We'll have another point. It will have a y value, and we'll take the change in distance over change in time. You will see in a second. We'll do an example. All right. So first example is about the distance in miles that a runner competing in Boston Marathon has traveled after a certain time t in hours can be found using this equation. What was the runner's average velocity between the second and the third hour of the race? So we have the second and the third hour of the race. Well, we could graph it, maybe, possibly, but I am not going to. I am just going to think about this for a second. So if I use what I had on my previous page, that would mean that I am going to find my average velocity using the formula for f of b minus f of a divided by b minus a. So what I do know is I know that I have a second and third hour. So I am going to plug in for time 2, and then I am going to plug in for time 3, and then we'll see what happens. So if I find the f of t, f of 2, that's the first one. So I'm going to see what happens after the second hour and plug it into my equation, negative 1.3 times 2 squared plus 12 times 2. Again, 2 is the number that I am plugging in. Well, if you have a graphing calculator, use it. If not, make sure you do the order of operation correctly. I already did that. That's 18.8. So my 2 hours into the race, it's 18.8. Let's see what happens when we do the third hour. So negative 1.3 times 3 to the power of 2 plus 12 times 3 is equal to, and I already did this one as well, and it was 24.3. All right. So I have my values that I need to plug in into my formula for the average velocity, and those values are, well, you can take either one of them first, and as long as you are consistent about keeping the order, I am going to take 24.3 first. I am going to minus 18.8, and I am going to divide it by 3 minus 2. Okay, so I have a change in distance. So this is the change in distance over the change in time. All right, so now once I calculated that, you can put this right into the calculator or whatever works best for you. The answer is going to be 5.5. And again, with those questions, it is always very important to write the answer just to make sure that you understand what you were asked. So for this one, the average velocity, I always misspell this, but it's E right in here, average velocity is 5.5 miles per hour. And that's it. So we did our first question. You will have one like this for your homework assignment. I kind of will line them up. We'll do 3 together, and then you'll get 3 that will be very similar to the ones that we are doing right now. All right, so let's go to example 2. In order to do the example 2, we need to talk a little bit more about different things. Instantaneous velocity, the velocity or speed that the runner achieved at the specific point in time. So what we want to do, because we want the specific point in time, we are going to use the formula we learned yesterday. But now we will say that our h, so that distance in between the 2 points, is going to be approaching 0. So it's going to be getting smaller and smaller and smaller until it disappears. And that is going to let us find the instantaneous velocity. So let's take a look at the question that we have. It's a long one. Well, I wrote it down. You can write it down as well, I hope. So this one is about the baseball. And the baseball is dropped from the top of the building, 2,000 feet above the ground. And the height of the baseball in feet after t seconds is given by the equation. So notice this is always fascinating me how something like this can be described with the equation. And find the instantaneous velocity of the baseball at 5 seconds. Well, let's see. So we are not writing a formula. This is actually going to be like the second type of the problems on yesterday's homework. So we are checking at the specific mark of 5 seconds. So let's see what this is going to bring us. So what I am going to do is I am going to start with the formula. And my formula is going to be defined as limit as h goes to 0, my f of t plus h minus f of t over h. That's what I want to calculate. That's the formula I have above. And let's see what happens. Again, we are going to plug in the 5 for t. So let's not forget about our limit notation. Limit as h approaches 0. I am going to have 2,000 minus 16, and then I will have t plus h squared, because in place of t I am putting t plus h, and then I am going to have minus and f of t, but in place of t I am going to put 5. So 2,000 minus 16 times 5 squared. Again, maybe I should, maybe I shouldn't, but I do want to encourage you to use the calculator for calculations like this, just so that we won't make mistakes. And we are going to divide it by h, and we are going to hope for the best. So we need to make sure we do this first. So I am going to have limit as h is approaching 0, 2,000 minus 16. Well, I have to do this out. This is going to give me, well, I didn't plug in the 5 for t, which I should have. Nobody said anything. So I will plug in the 5 for t, and I will multiply it out. So 5 squared is 25, plus 5 times h is 5h, plus, times 2, 10h, plus h squared, minus, And I did this part on the calculator, and that gave me, I think, 1600. Well, I think it was 1600, but let me see if it's still on my calculator. Yes, it was 1600. Again, as always, we need to keep cleaning this expression out because the h is in the denominator, h is approaching 0. This is impossible in the form it is, so we need to make sure we are able to clean it up somehow. Limit as h approaches 0, 2000 minus 16 times 25 was 400, minus 160h minus 16h squared and minus 1600 divided by h. 2000 minus 400 is 1600 minus 1600. That is going to beautiful. That is going to be beautiful because it is going to cancel out. So those numbers are disappearing. So the only thing we have is 160h minus 16h squared. And we are going to divide it by h. Again, this is problematic because if I plug in 0, I am getting 0 by 0. I can't have that. But what I think everybody should be able to notice at this point, we can at least take out h. And the reason why I'm not taking the number out is because I know that I want to cancel the h's out. So I have negative 160h minus, no, not h right here, 160 minus 16h. And h and h cancels out. Once you figure this out, we will plug in 0 for h. This is going to give me 0. And my answer is negative 160. And again, I do want to encourage everybody to make sure that you understand what did we just find. So now, first of all, we got a negative number. And the negative sign means that in this case our height is decreasing. My husband is watching some TV show and it's very loud. Maybe you can hear the music. I sure can. So the height is decreasing, that's why we got the negative 120. And notice we found the instantaneous velocity. I've been practicing to say this word. And that is negative 160 feet per second. So we will say the 160 feet per second. The velocity, we would have the 160, but again, because the height is decreasing, that's why we have that negative number, all right? So keep that in mind. Okay, one more. So notice this was at a specific time, and we did not create a formula. We got the exact answer. Now we are going to have a question where we will, well, let's see. So I have a distance, a particle moves along a path is given by this equation. And again, fascinating, something like this can be described using an equation. And where t is given in seconds and the distance of a particle from its starting point is given in centimeters. Find the equation for the instantaneous velocity of the particle at any point. Okay, so we want at any point, so we will have some kind of equation as our answer. Okay, so again, let's start with the formula. V of t is equal to limit as h approaches 0 of, well, this was s of t, so I am going to say s of t plus h minus s of t divided by h. And let's plug this in. So limit, let's not forget about that. 18 in place of t, we'll plug in t plus h. minus 3 and then t plus h to the power of 3 minus 1. So this is the first part where I plugged in t plus h in place of t. And then I will have minus, make sure you put this in parentheses, that's important, and 18t minus 3t to the third minus 1. This is just my s of t divided by h. All right, again, we need to do the cleanup. When I was working with some of your friends today, I used the binomial theorem for something like this, and I will do the same thing in a second. So limit as h approaches 0. I can multiply this using the distributive property. So 18t plus 18h minus 3. And I know that if I am raising something to the third power, the Pascal's triangle look like this. 1, 2, 1, 1, 3, 3, and 1. So those are my coefficients. Where am I here? So t to the third plus 3t squared h plus 3th squared plus h to the third minus 1. Well, minus 1 is going to be after the parenthesis. And now I'm going to clean up this, make the signs as they're supposed to be, because I am distributing the negative. So minus 18t plus 3t to the third plus 1. This is very interesting and long, divided by h. And I really hope I won't make a mistake. Limit as h goes to 0. Let's see, we need to use this distributive property. There's nothing we can clean up in this parenthesis. But I'm trying to think, look at this one, 18t minus 18t. I can get rid of that. I want more because that will be less writing. So negative 1 and positive 1, that's gone. And I think everything else I need to rewrite. So it was worth to stop for a second. And we cleaned up some things. All right, so 18h minus 3t squared to the third minus 9t squared h minus 9th squared minus 3h to the third plus 3t to the third, and that's all. H is on the bottom. So now let's see. There's nothing I can do with this term. This is convenient, negative 3t to the third and positive 3 to the third. And what I do want is I do want to take h out of every single term, and I see it's possible. So limit as h goes to 0, h 18 minus 9t squared minus 9th minus 3h squared divided by h. Again, I did this because if you try to plug in 0 in place of h, that is impossible, that is problematic. So we factor h from every single term, and we got some expression that looks like this. So now, when you plug in 0 for h, this term is going to be 0, this term is going to be 0. So now this is all equivalent to 18 minus 9t squared. And this is going to be our formula. So the the answer, instantaneous velocity of this particle, is going to be described with the formula 18 minus 9t squared. Done and done. Well, that was fun. Again, we are getting closer and closer to what the calculus is about. Well, actually, we are already working on the calculus problems. So please try to practice. As I said, example 1 on the practice page is going to line up with example 1 from the notes, and 2 and 3. And if you have any trouble, come see me. Maybe we'll have even more people tomorrow. All right, and enjoy your day tomorrow.